So in our previous class, we have learnt one problem. In today's class, we will continue with the problem. Two charges, 5 into 10 to the power minus 8 coulomb and minus 3 into 10 to the power minus 8 coulomb are located 16 centimeter apart. At what points on the line joining the two charges is electric potential 0? Take the potential at infinity to be 0. Okay. Let us consider two charges, which and all? 5 into 10 to the power minus 8 coulomb and minus 3 into 10 to the power minus 8 coulomb. They are separated by the distance, how much? 16 centimeter. Okay, they are separated by the distance 16 centimeter. You have to find out where the at what point the potential is 0. So let us consider somewhere here the potential is 0. Let us mark it as O. Let this distance be x and this distance be 16 minus x. Correct? 16 centimeter minus x. Next, how can we solve? Further, how can we solve? We know the expression V is equal to 1 by 4 pi epsilon naught Q by R. Use this for this one. Let this point be A and B. So, okay, VA is equal to 1 by 4 pi epsilon naught. Q is 5 into 10 to the power minus 8 divided by X. VB 1 by 4 pi epsilon naught minus 3 into 10 to the power minus 8 divided by 16 minus X. At the point O, we have to say potential is 0. So, VA plus VB is equal to 0 at O. Correct? So, now if you substitute and calculate, I think you will get answer. Substitute and calculate. Solve. That is 1 by 4 pi epsilon naught 5 into 10 to the power minus 8 by x plus 1 by 4 pi epsilon naught minus 3 into 10 to the power minus 8 divided by 16 minus x is equal to 0. Which is common here? 9 into 10 to the power 9, 5 into 10 to the power minus 8 by x, minus 3 into 10 to the power minus 8 by 16 minus x is equal to 0. Take 9 into 10 to the power minus 9 the other side. Sorry, 9 10 to the power 9 to the other side. So what is the answer you get here? What is the answer you get? 9 into 0, something divided by 0 is 0. So 5 into 10 to the power minus 8 by x minus 3 into 10 to the power minus 8 by 16 minus x is equal to 0. Let me take this other side. So we get 5 into 10 to the power minus 8 divided by x is equal to 3 into 10 to the power 8 minus 8 divided by 16 minus x. Cross multiply. So we get 16 minus x into 5 into 10 to the power minus 8 is equal to 3 into 10 to the power minus 8 into x. So if you open the bracket, we get 16 into 5 minus x into 5. 80 into 10 to the power minus 8 minus 5x into 10 to the power minus 8 is equal to 3x into 10 to the power minus 8. What is the answer? What is the answer? Into 10 to the power minus 8 is equal to 8x into 10 to the power minus 8. Correct? Then, next step. Is equal to 8x. X is equal to 10 centimeter. So, we got the value. X is equal to 10 centimeter. So, at 10 centimeter, the potential, electric potential is 0. Is this the only one point where potential is 0? No. Somewhere else also line joining the two charges. So this is the first one. So they have given here line. So what are the points they have asked? See, not point, points. So next point, where it might be 0. So here, if x is equal to 10 centimeter, then we get the potential is 0, or else 16 minus 10, that is at a 10 centimeter from B. This is 10 centimeter from A, and if we minus 10, 6 centimeter from B. The solution is that. Next, one more, where it is 0, you have to find out now. Can you help me to say where it is 0? Second one. 5 into 10 to the power minus 8 minus 3 into 10 to the power minus 8 coulomb. The line joining them is 16 centimeter. Let us say from where here O, it is 0. Let this distance be x. Now if you want, you can change it as y. No problem. Then total distance is 16 plus y. Correct? Yes. Now help me. Potential. So total distance you want to write? Okay. 16 plus y. Due to A on O, potential due to A on O is 1 by 4 pi epsilon naught Q by R. VB, due to B, potential at O, minus 3 into 10 to the power 8 divided by, y. Potential is 0 means VA plus VB is equal to 0. Therefore, now 9 into 10 to the power 9, 5 into 10 to the power minus 8 by 16 plus y, plus 9 into 10 to the power 9 into minus 3 into 10 to the power minus 8 divided by y is equal to 0. Like previous one, these are same, common, take it to other side. So the remaining is 5 into 10 to the power minus 8 by 16 plus y plus minus 3 into 10 to the, because plus into minus is minus 8 divided by y is equal to 0. Let us take this one to other side. So what do we get? 5 into 10 to the power minus 8 by 16 plus y is equal to 3 into 10 to the power minus 8 divided by y. Minus 8 will go. Take denominators to other side. So 5y is equal to 3 into 16 plus y. So 5y is equal to 16 3s are 48 plus 3y. Let us take 3y other side. So we get 2y is equal to 48 and y is equal to 48 by 2. Y is equal to 24 centimeter. So at 24 centimeter from B, you are having potential, electric potential 0. Or at a distance 16 plus 24, if you add, at that distance electric potential is 0. So there are 2 points where you can say the potential is 0. If you keep it other side, one more distance, but small changes in the value. Okay, so if you calculate for 2, it's enough. Understood? So for one, somewhere in between the 2 charges, another one, 2 charges are there somewhere outside. Okay. Next, shall I give one homework? Try to solve one homework problem. Two-point charges, 5 nanocoulomb and 10 nanocoulomb minus 10 nanocoulomb are located at .3 meter apart. Are located 0.3 meter apart. At what points on the line joining? At what points on the line joining? At what points of the line joining the charges where the potential is 0? Other things are same. Homework. 5 nanocoulomb minus 10 nanocoulomb are located 0.3 meter apart. At what points on the line joining of 2 charges is electric potential 0? Take potential at infinity will be 0. Try to solve this homework. Next, solve one problem. Point charges. Plus 2 nanocoulomb plus 4 nanocoulomb and plus 8 nanocoulomb are placed at the corners A, B and C respectively of a square. A, B, C, D of side .2 meter. Calculate the work required to transfer a charge of 2 into 10 to the power minus 9 coulomb from C to the D. From D to the center. From D to the center of the square. charges plus 2 nanocoulomb plus 4 nanocoulomb and plus 8 nanocoulomb are placed at the corners A, B and C respectively of a square ABCD of side 0.2 meter. Calculate the work required to be transferred a charge of 2 into 10 to the power minus 9 coulomb from D to the center of the square. In the previous problem what we have solved, that is you have to move a charge, that is electron, from center to D. Here from D to center. Okay, let us draw a square A, B, C, D of side 0.2 meter plus 2 nanocoulomb plus 4 nanocoulomb plus 8 nanocoulomb. Center B O. Transfer a charge from D to O. Okay. Let us calculate at D. But we don't know this distance. We can calculate using the distance OA, OP, OC, OD can be calculated by using a Pythagoras theorem. That is AC square is equal to AB square plus BC square. AC is equal to square root of 0.2 square plus 0.2 square. That is AC is equal to, what is the answer? You get 0.4 square plus 0.4 square. That is equal to 0.8. Square root of 0.8 is nothing but 0.283. 0.283 meter we get. Then, what is the distance? If this is 0.283, what is the distance of OA? OA is equal to AC by 2. That is equal to 0.283 by 2. What is the answer? We get 0.141 meter. 0.141 meter we get. Next, OA is equal to OB is equal to OC equal to OD. Hence, next formula. Use the formula of potential difference. V is equal to 1 by 4 pi epsilon naught Q by R. Potential at O is Q1 by R1 plus Q2 by R2 plus Q3 by R3. VO is equal to 9 into 10 to the power 9, because 1 by 4 pi epsilon naught is nothing but 9 into 10 to the power 9 into Q1 2 into 10 to the power minus 9 by R1, that is 0.141, correct, plus Q2 4 into 10 to the power minus 9 by 0.141 plus 8 into 10 to the power minus 9 by 0.141. What is the answer? Take a calculator and solve. Please give me the answer. 893.6 volt. 893.6 volt is the solution. Next, what you have to do? You have to find out potential at D. Potential at D. How to find out potential at D? VD is equal to, see here, this is R1, R2, R3. VD is equal to now which is R1, R2, R3 for VD? For VD, this one R1, this is full R2, and this one is R3. So therefore VD is equal to 1 by 4 pi epsilon naught Q1 by, I'll write AD, then it'll be easy, no? Plus Q2 by BD plus Q3 by CD. Is it easy now? Instead of R1, R2, R3? That's better, I think, correct? AD, BD, CD. Substitute and calculate. 9 into 10 to the power 9. Q1 is how much? 2 into 10 to the power minus 9 divided by 0.2 plus Q2. 4 into 10 to the power minus 9 divided by, what is this distance? 0.283, something you got, correct? 0.283 meter. Plus 8 into 10 to the power minus 9 by 0.2. Now calculate what is the value of D. 577.2 volt we got. 577.2 volt we got. What did you get? Try. Next, work done is nothing but charge into potential difference, correct? Work done is equal to charge V into Q. But what is a V? V is nothing but change in potential. You have to move a charge from where to where? From D to O. So, VO minus VD into Q. See, always from where to where you are moving, you have to see. If you move a charge from A to B, potential difference is VB minus VA. If you move a charge from B to A, then VA minus VB. Understood? Don't forget this. If you move a charge, and this one. If you move a charge from A to B, VB minus VA. If you move a charge from B to A, VA minus VB. Here you have to move a charge from D to O. So VO minus VD into Q. Because see, work done is potential is nothing but work done per unit charge. So I can say work done is equal to V into Q. V is nothing but here change in potential difference. Okay, W is equal to, what is that value potential difference we got? What is that value we got? One is 893.6. Another one is 577.2. 893.6 minus 577.2 into Q. What is the value of Q? 2 into 10 to the power minus 9. Because they have given you the value of charge. That time in the previous problem it was electron. Now it is a charge, that is 2 into 2 nanocoulomb. So substitute it here and calculate what is the work done in moving a charge from D to O. Answer is 632.8 into 10 to the power minus 9 joules. Did you get the same? To 10 to the power minus 9 joules. Did you get the same? Try to solve. Next, write one homework. Write one homework. Charges charges 3 nanocoulomb, 5 nanocoulomb and minus 4 nanocoulomb are placed at the corners A, B and C. Are placed at the corners A, B and C of a square ABCD of side 6 centimeter. Find the work done in moving an electron. Find the work done in moving an electron from D to the center O. From D to the center O of the square. Same like this problem itself, how you have solved. Here the charge is nothing but an electron, so you have to use 1.6 into 10 to the power minus 19 coulomb value. And same thing, because it is, you have to move from D to O, so VO minus VD you have to use. Try to solve. Okay, thank you.